Hi, Cody. Hi, Jude. Oh, so many new names. How exciting. There is a question up on the board that you can try so long. If you need help, let me know. You're welcome to talk in the comments, or you can just unmute yourself and chat to me. Those of you who didn't have your sound on just now, there's a question up on the board. Give it a try. If you need help, let me know. Ask away. You can put your questions in the comments, or you can unmute yourself and chat to me. Both are fine. We're just going to wait for a few more people to join, and then we will get going on these questions. But this one should feel similar to something we did on last week, Wednesday. Just gonna put a little helping hand here. Hello to the people who have just arrived. Welcome. Second last lesson of Pythagoras. We're going to do all kinds of questions today. But we're going to start with something that we did on Wednesday, and that is the question up on the board. So give it a go. Ask for help when you need. And we're just going to wait for a few more people to come. And once you are happy with your answer, please feel free to put your answers in the chat. I see some familiar names. Hi, everyone. Okay, so give this question a go. See if you can find x for me. I've tried to help you a little bit with the orange that's on the left, which is just reminding you of what we did last week with Pythagoras and right angled triangles. So do your best. And when you have an answer, put it in the chat for me. Remember, it doesn't matter if it's right or wrong. I just want you to try. Have we got no answers for x coming in just yet? Do you need more time? Is that what this is? Or are you feeling completely lost? Give me an idea of where you are. So let me know, are you still working on it or are you just completely lost?
Ma'am?
Yeah.
Divide the cube by 2.
The 32?
Yes, ma'am.
Yes, you're definitely on the right track. It's okay. Thanks for letting me know. Cool. Need more time. I'm happy to give you more time. Okay, Bridzi, don't worry. I'm just going to let the others work on it for a little bit, and then we will talk through it nice and slowly together. Does anyone have any maths tests that are coming up this term, or do you only write exams in fourth term? Let me know. Canva. Okay, Canva, you're on the right track. You're very, very close. But there's a step that's missing. Writing a math test on Friday about data handling. Okay, cool. Data handling is a nice section to do well in because they always ask very similar questions. So that's always nice. Do you have any other tests coming up? Who's got maths tests this term? Only an exam. Okay. That gives you lots of time to be ready then, which is nice. Possibly you? That worries me that you don't know if it's definite. Maybe something to find out? Okay. All right, guys, I'm going to start going through this question. So let me turn this off. Okay, here we go. Cody, so only an exam. Okay, cool. Well, one of the things that we have scheduled is a question and answer thing, as far as I remember. So you can ask all the questions you're needing to get ready for your exam closer to the exam.
Ma'am?
Yeah.
Is the answer a decimal?
The answer is not a decimal, no. Oh, and transformation. Oh, and we did some transformation last term. That's cool. Okay, so let's have a look at this question. So with Pythagoras, I'm seeing a good answer in the chat over there. Our hypotenuse. Oh no, you know what? I did it wrong. I think the answer could very well be a decimal. I was happily thinking give me a second. It is definitely a decimal. Okay, I just forgot to square my hypotenuse when I did this by myself. Okay, so our hypotenuse squared is equal to our one side squared plus our other side squared, and that is, the reason is Pythagoras. That's okay, thanks for letting me know, Lorato. So if anyone also got 4, it's because you forgot to square the 32, like I did when I practiced this at home. So next step, we are going to square that 32 and we get 1024. And x squared plus x squared, these are like terms, which means they are the same as each other. So we can add them together and we get 2x squared. Now we need to divide both sides by 2 so that x squared is alone. So we're going to divide that by 2. And then we need to square root that 512. So the square root of 512 is going to be x, which means x is 22,63. That is what I get. Now, let's see. Do we have anyone in the chat who got anywhere near there? Let's have a look. Okay, we all got very different answers. Let me double check these just to make sure. So 32 squared, 1024, good, divided by 2, 512, cool, square root of 512. Okay, I'm definitely happy with this answer. Those of you who got a little bit off, can you see where you went wrong, at which level you sort of took a detour? Or not so much?
I didn't add the like terms together.
Ah, okay, that makes sense. Tiamo, did you do the same thing that I originally did and not square that 32? I think that's maybe where your 4 came from. Let's see. Okay, cool, guys. We're gonna move on today. So does anyone need me to sit here? Can I scroll down? If you ever need more time, just got a bit lost. That's okay. It's also the first lesson of the week, and we did this a while ago, so don't panic. If at any point you need me to stay somewhere, you can either let me know in the chat, or you can just use the emojis and just put the hand up emoji, and that lets me know that you just need to wait somewhere for a little bit. Okay, so just try and let me know. Don't ever let me scroll past something that you're still needing. Okay, I thought we could do one sort of trickiest-ish question along the same lines of what we were doing last week, Wednesday, before we jump into what we're going to do today, which is isosceles triangles and Pythagoras. So I thought this might be a nice question to try. I'm going to help you scaffold it a little bit before you get going. So let's just talk about a couple of things here. Who can tell me what the length of EB is? What would be the length of EB? Beautiful, Kumba. Nice. 4.5 centimeters. Okay, cool. Now I would like the length of AB. You got to think about it a little bit.
6 centimeters.
Yes, Princey. Yes, 6 centimeters. Okay, so for those of you who are not seeing that, this part over here would be 10 centimeters. Nice, Cody. And this whole part over here has to be 16, which means that AB has to be 6 centimeters. Okay, so that's where I'm going to stop helping you. I've kind of done all the hard work for you, but now I just want you to practice some Pythagoras here, and I would like the length of EA, which is that length over there. So get your calculators out, get writing, see if you can find me the length of EA, and then put your answers in the chat for me when you are ready. Or unmute yourself and talk to me. You know I love hearing your voices.
Ma'am, his answer is 7.5 centimeters.
Yes, look at you. So awesome. Okay, 7.5 centimeters is 100% correct. So now let's just talk through how we would write that. Because remember, when maths is all about writing it in a very specific way, we're very, very fussy as maths teachers. Okay, so we're going to write our hypotenuse squared. So EA squared is going to be equal to our one side, so 4.5 squared, plus our other side squared. And then we have to give our reason of Pythagoras. If we don't give that reason, then we won't get our mark. Okay. And then we can put that 4.5 squared plus 6 squared into our calculator, and we get EA squared, which is equal to 56.25. Okay, so Nokubonga, did you get to the same number as I have over here? Because it might be that something went wrong in the adding process.
I gotten 52.25.
52.25.
Yes.
Okay, I think something then just happened on your calculator. Can you do me a favor and can you try chuck that into your calculator again for me?
Okay, ma'am.
Thank you. Okay, so we get, I'm just going to wait and see if we get to what we're wanting. Okay, and then we are going to square root that. And we get the beautiful answer. So I'm just going to write all of these steps over here in case anyone is feeling completely lost. And so therefore EA is going to equal 7.5 centimeters. So all of you who got that, well done. Give yourselves a big pat on the back. Now, obviously in this question, the hard thing was figuring out the two lengths that we didn't know. I did help you a bit with that, but I'm not going to help you in some of the questions we do on Wednesday. So this was like my helping hand. Okay, does anyone need to sit here? All right. So today we move into Pythagoras in isosceles triangles. Who can tell me what an isosceles triangle is?
When two sides are equal.
The triangle.
Yes. Okay. So an isosceles triangle is when two sides are equal. Okay. And like we've also learned, when we have an isosceles triangle, the angles, the base angles are also equal to each other. So in this triangle, remember we show equal sides by little lines. So we can have two lines. That means that let's label this triangle. So let's call this triangle ABC, for example. A, B, C. Okay, those little blue lines mean that AB is equal to AC. We don't have to have two. You can also just have one line like that. And whenever we have a line on top of a line like that, it's meaning that they are the same as each other. So this is telling me that AB is equal to AC. And so we know it's an isosceles triangle. Now, the thing I was talking about just now is in an isosceles triangle, we also know that our base angles are the same as each other. So that angle is the same as that angle in an isosceles triangle. Now, sometimes what we need in isosceles triangles is something called a perpendicular height. So let me write down what that word means. So perpendicular heights. Who can tell me what the word perpendicular means? Do you need a hint? My hint is that. So yes, it does bisect, but that's something we're going to talk about just now. Perpendicular is not necessarily going to bisect something, but bisect is a word we're going to talk about just now. Does my little upside down T not give anyone a hint as to what perpendicular is? What if I, yeah, sorry?
Lines with 90 degrees.
Yes, 90 degrees. 90 degrees. Perpendicular means it is at 90 degrees. Okay, so thank you, Piwe and Okobongo. Thank you. So a perpendicular height is saying that we have the height of the triangle. So something from one vertex of the triangle to a base of a triangle. And it has to be at 90 degrees to the base. Okay, so because when we're working out area of a triangle, which is what we're going to be doing in our next few sessions, we need to have a perpendicular height. So a perpendicular height is when we go from the vertex of a triangle. Remember, vertex is a point where two lines meet, to the base of the triangle. And it is at 90 degrees. And so we are creating two 90-degree triangles. Now, the word that came up in the comments, which is a really, really good word, is bisect. Okay, so bisect kind of sounds like dissect, which is something you do in biology, you know, when you dissect rats and kidneys and all those things. Bisect is similar, so we're cutting something, but we are cutting it in half. So exactly in half. And whenever we have an isosceles triangle, we bisect the base, which means we cut the base in half. So what do I mean by that? I mean that if BC, so that whole line BC was 10, then this would be 5 and that would be 5. We are cutting it exactly in half. So what we land up creating are two triangles that are exactly the same as each other. So this triangle here is exactly the same as this triangle here. And can anyone remember the word for when two shapes are exactly the same as each other? Something we did together. Two something triangles.
Similar.
Congruent.
Congruent. Two congruent triangles. Okay, congruent, and the symbol for congruency are those three horizontal lines. Okay, so when we draw a perpendicular height in an isosceles triangle, we bisect the base of that triangle and we create two congruent triangles within the big triangle. Does anyone have any questions about anything I've said here that doesn't make sense, or definitions of any words that they don't know, or anything you'd like to add here? Or if you just need more time writing this down. We're all good. Okay, cool. So let's try and work with a question then. Okay, so in this question, I'm saying find the perpendicular height, which is what we've just spoken about, okay, of the following triangles. Now, perpendicular height is from our vertex to our base at 90 degrees. And I'm going to call this A, B, C, D. I would like, because I'm wanting the length of the perpendicular height, I would like the length of AC. And I would love it if you guys could try this question by yourselves and tell me what that height of AC is. We will obviously go through it together. I just would like you to give it a try first. You should get a nice answer that doesn't have decimals.
No.
See, did you unmute yourself just to sneeze?
Oh, sorry, ma'am. I didn't know. I'm sorry, ma'am.
Okay. Okay, we're getting some different answers coming in. How was okay? All right, let's have a look. I'm liking these answers that are coming. So, what we spoke about earlier. Oh, it's okay. Well, I'm gonna talk about this super slowly. Okay. What we spoke about. Hello, Eleanor. Is that when we create this perpendicular height in a triangle, we bisect the base. Okay, and bisect the base means we cut the base in half. So that means if this whole distance here is 16, that means that this part here is 8 and this part here is 8 because 8 plus 8 is 16. Okay, now I'm wanting this perpendicular height. I'm wanting AC. So I'm wanting that yellow dotted line. I can work in either one of those triangles because they are exactly the same as each other. So let's say I decided to work in this triangle over here. Okay. I'm going to use Pythagoras. I can see that my hypotenuse is 10. My one side is 8 and AC is what I'm looking for. So I can say 10 squared, that's my hypotenuse, is equal to 8 squared plus AC squared, Pythagoras. Is it 8 or 18? It's just 8. So this distance down here, let me make this a little bit bigger. This is 16. And so when I bisect it, I'm going to create a side that's 8 and a side that's 8 because 8 plus 8 is 16. So now I land up with this story over here. So I can just move that around a little bit. 10 squared minus 8 squared is equal to AC squared. And that we can chuck straight into our calculator, which gives us 36. And so the square root of 36 will be AC, which means AC is equal to 6. And then it could be centimeters or units or whatever. Okay, those of you who are feeling a little bit lost, does what I've said, does this make sense? Because we're going to do something similar to this just now. So it's important to me that this makes sense to you.
Yeah, it does.
Yay, good. Good. Do we have Zinhle today? I don't think I've seen. Oh, no, I see Zinhle. Okay, because we have a surprise. Oh, wait, hold on. Does anyone need me to sit here any longer? Hey, Zinhle. Okay, please re-explain that. Yes, sorry. Okay, so yeah, let me go through this one more time, and then we're going to go to our little challenge coming your way. Zinhle is our current champion. Let's see if they can be overthrown in their ruling. All right. No, but now we just get to raise anticipation. Okay. So, Eleanor, do you have a question? No? Okay. So yeah, let's just go through this quickly. Our whole base over here is 16. And when we create our perpendicular height only in an isosceles triangle, okay, we bisect the base, which means we're cutting this base in half. And so one side will be 8 and the other side will be 8. Then I can choose to work with either one of those triangles because they're exactly the same as each other. So I'm going to work in this one that I have highlighted yellow. And I'm going to say my hypotenuse squared is equal to one side squared plus AC squared because of Pythagoras. Okay, I'm going to move that over till we get to this point over here. If I chuck that into the calculator, I'm going to get 36 is equal to AC squared, which means AC is equal to 6. Okay. Okay, guys, if you don't have paper,
Yes,
get
ma'am,
that
sorry.
paper ready. No worries here, no worries. Get that paper ready for the little thing that's coming up your way. Let's see who can solve this first. I'm wanting to know what a red sweet plus a pink sweet times a blue sweet is. Let's see if Tula can beat you all. I challenge him. I'm going to make him send me a direct message so that he doesn't ruin it for anyone else. No, Chamo, don't say it out loud. Otherwise, people will know. But when you have your final answer, put your final answer in the chat for me. And I'll let you know if any of you give me an answer before Tula gives me an answer. See if you can beat him. Tiamo, is 6 times 6 times 6 27? Just gonna leave that thought there. Okay.
Ma'am, his answer is 72.
That is not the answer I have. We're in decimals now.
Ma'am, is the answer 24?
That is also not the answer I have. I will double check my answer. I have seen one answer that's really close to my answer, but it's not the same as my answer.
The answer 22, ma'am.
Also, not what I got. I'm
Ma'am,
fairly, yes, hello.
is it 24?
It is not 24. I'm very confident in my answer, and I can tell you that there are a few of you who are very close, but
Is it 10?
it's not. Zinkler, you went from 12 to 48. What happened there? Kinsani, I also don't get 24.
It's 9, ma'am.
It's not 9.
Is it 32?
It is not.
Ma'am, is it 16?
It's not 16.
Is it 18?
No, are we just going through all the numbers now?
Is it 30?
It's not. It's not 30. Not 55. Not 72.
Ma'am, I'm stuck at 12.
Ah, Jude! Jude just got it. 13. It is definitely 13. Yes, well done, Jude.
How is it 13?
Yeah, Sinclair, you have just been overthrown, Sinclair. Okay, let me explain how this number is this number. Well done, Jude. Okay, so let's have a look through this. So first thing that we would have to start with is let's kind of break down our sweets. Let's see who found out what. So what was our value for our blue sweet? That should have been the easiest place to start.
3.
3. Okay, so we knew that our blue sweet was 3 because 3 times 3 times 3 is 27. Okay, so it would be like what number times itself would be 27. So we knew that the blue sweet was 3, which means we know that that number there is 3. And now here in the second line, we've got 2 3s together. And so that's going to be 6 because they're 2 3s, because they're 2 sweets. And we need to figure out 6 times something has to give us 12. And so that has to be 2. And there are 2 red sweets, which means up here, there would only be 1 because there's only 1 red sweet. And then we get into our pink situation, and something times something has to equal 16 because something times 1 is itself, which means this has to be 4 and this has to be 4. And then we have all of our numbers. So we've got 1 plus 4 times 3, and 4 times 3 is 12, and 1 plus 12 is 13. And Jude is our current winner.
Ma'am, how come I didn't see the plus sign?
I don't know why you didn't see the plus sign.
It was not there.
It's there. It's right there. I could see those of you who got 12. I knew you were so close and you had just made a silly mistake. That's why I was trying to tell you, you're super, super close. See ya. Don't be salty. You can get in the next one. You just have to be faster than Jude and Sinclair. You were all so close. So many of you who got 12, you were so, so, so close. I think you were just saying 1 times 4 times 3. Okay. That was fun. Let's get into our Pythagoras mode again. Okay. So now this one is very, very similar to the one that we had just done. And now I'd like you to try this one all by yourself. You are going to get a decimal answer, and I would like your answer rounded off to 2 decimal places. So I would like the perpendicular height of this triangle. I'm not going to help you at all. I'm not going to draw anything in. I want you to figure this one out now by yourselves. And then we're going to go through the answer together. Sure, so quickly. Okay, so we've got some different answers coming in. I'm going to let you just, I can tell you that one of the answers in the comments is correct. Okay, let's go through this. I think some of you who have a bigger answer, what may have happened is you forgot to bisect your base. So let's have a look. Let's give it a try and see what happens. So, oh, goodness, just zooming in. Our perpendicular height would be this little line over here. Perpendicular means it's at 90 degrees. Height is saying from the vertex to the base. And when we create that perpendicular height, we bisect our base. So we have 11 and 11. I think what happened to some of you with those big numbers, you maybe did not bisect that base. And so now we are looking for this perpendicular height. I'm going to call it X because I don't know what it is. Okay. So I'm going to say my hypotenuse squared is equal to my one side squared plus my other side squared because of Pythagoras. Okay, I'm going to move that 11 squared over, and I'm going to chuck that into my calculator, and we get 75 is equal to X squared, and the square root of 75 is 8,6. Yay, you did it exactly like me. Amazing. Beautiful. Okay, well done, guys. We've got a couple more questions that I want us to get through this evening, and then I'm going to let your brains have a rest. Okay, so again, I'm not going to help you. I just want us to talk about a couple of words that are in this question. So perimeter, that's something we spoke about last week, Wednesday. Perimeter means the whole edge, so the outside of the shape. Okay, so I want the distance of the outside of the shape, and I want my answer rounded off to 2 decimal places. And these lines here tell me that they are the same as each other. Okay, so it's telling me it is an isosceles triangle. And I would like you to give this question a try for me to tell me what the perimeter is. It is a decimal answer. Yeah. So just be careful with your answer. I'm wanting the whole perimeter. So I'm wanting that whole yellow outside. Okay, let's see some of these answers. Okay, I have seen, let me go through this chart. So there's one answer which is 99.9% correct. But they're not giving me an answer to 2 decimal places. And only one of them so far. Okay, I'm just gonna do a little bit of a helping hand there, see if that helps anyone.
Ma'am,
Yeah,
ma'am. So
yes.
answer 25,6.
Nope. Okay, so those of you who are giving me 1 decimal place, I think I know why you're doing it. And I'm not actually unhappy about it. So I'm just going to go through what you have got here so far. So through Pythagoras, if I'm going to make this x over here, and I know that that's also x over there. Okay, so Pythagoras is telling me that x squared would be equal to 10 squared plus 8 squared because of Pythagoras. Okay. And so that means that x squared is going to be 10 squared plus 8 squared, which is 164. And so if we square root that, we're going to get this answer of 12,8. Now, lots of you, I think, would have stopped at that 12,8 because the next number is a 0. But when we haven't finished our answer, it's really important for us to keep more decimal places, because otherwise we don't get like the fully correct answer in the end. You're not wrong. It's just it doesn't have all the number of decimals, and the question specifically asked for 2 decimals. Okay. And so now I know that this side here is 12,806, and I know that this side is 12,806, and I know that this side is 16. So my perimeter, I'm just going to add those together. And I should get 41,61. So those of you who were very, very close, there were quite a few people who had 41,6. And like I was saying, I think what happened was you rounded that to 12,8. Because then that would have worked out that way, which is fine. Just where possible, try and keep more decimals until you have your final answer. Okay, cool. Let's see. I've got a similar one to that. So if you didn't get this one right, make sure you're happy with everything I've done here, because you said 12,8 plus 10. Oh, okay. Thank you for saying that. So they're wanting the perimeter of this whole triangle. This 10 is not part of our perimeter because it's not on the outside of our triangle. It's on the inside. Our whole triangle would be this side here, and then this whole side. You were working out the perimeter of a baby triangle on the inside, not the big yellow triangle. Okay. Okay, no worries. Let's see. Does anyone not know where they went wrong with this question and they would like a little bit of help before trying a similar one?
Ma'am,
Yeah.
can I ask, how did you get that 12,806?
Okay, so I got that by using the Pythagoras theorem that we've been working with. So when I have my, when I put in this perpendicular bisector over here, it breaks up that 16 into 2 equal parts. So I know that this side here is 8, and I know that that side there is 10. And so then I can use Pythagoras to find my hypotenuse, which is x. So I'm going to make x squared equal to 10 squared plus 8 squared. And if I solve for x, I get 12,806. And now once I have that number, so from here, if you're feeling confused, that's the same as saying x is equal to the square root of 164. And so then we get that answer, and then we can add all 3 sides together. Okay. All right, cool. Let's see if everyone can get this one right now. It's a slightly nastier one. And I'm going to be very fussy about my decimal places here. Okay, we got some answers coming in. We're gonna stay quiet until some more people have answered. Can officially say that I have one answer in the comments that is 100% correct.
Ma'am,
Yes.
is the perimeter 44,25?
I can say that that answer is 99.9% correct.
Okay, ma'am.
Is it 44.26?
I can confirm, Kamba, that that is 100% correct. Let's go through this. There we go. Okay. All right, step by step. So first things first, our perpendicular bisector here, that perpendicular height breaks this up into 10.5 and 10.5. Okay, so it broke up that base for us. And so now I'm going to make this side x, which means that side is also x. And I can say that x squared is equal to 5 squared plus 10.5 squared Pythagoras. Okay. So let's chuck that in. And so x squared is equal to 135,25, which means x, we're going to square root that. And we get 11,6297. I'm going to write 4 decimals. You can write 3. You should still get to the right answer. Okay, so now I know that this side over here is 11,6297. I know that this side is 11,6297. And I know that this side is 21. And so I can just add those together. And we get the beautiful answer of 44, and I'm going to write the whole thing in here so that you can see what your decimal places look like. Now, the reason some of you got a slightly different decimal place is either because you didn't round off properly or because you rounded these ones off a little bit earlier, and that's okay. I'm not angry if you got oh goodness.
Ma'am?
Yeah.
I'd rounded mine to the nearest third decimal place.
For these ones.
For the yes.
Okay, yeah, that's fine. So that's totally okay. And that's why it was a little bit different. And I'm very happy with that answer. Everything you did was beautiful. So if you did do it to this point here, and you've got that 9 chilling over there, it's going to affect that 5, and that's then going to become 44,26. And that's where we land up with. So some of you may have gotten to here, and then you didn't look at that 9. And the 9 changes to 6. Okay. All right. We have got one more question for the evening. And then we're gonna go from there. 44,25. Yeah, that's cool. So then the 8 just after the 5 is going to round the 5 up to a 6. Okay. Okay. I'm actually not going to do that question. I'm going to jump to a question that we didn't finish off last week, Wednesday. This one over here. Okay. And I'm not going to let you worry about all of those fancy words over there. all I want to know is what this whole length is, what that whole long yellow length is. That is the last thing I need your brains to think about this evening. And when you have your answer, let me know. Are you just joking because you're worried you're wrong? Because you're very, very close.
Is it 65?
It is 65. Yes, guys. Look at how fast you just did that. That's crazy. Okay. So 60. Oh, that is not 61. 61 squared is equal to 11 squared plus x squared because of Pythagoras. Good. X is 60. Well done. Okay. And so 61 squared minus 11 squared is x squared. Chuck that into our calculator. And we get 3,600 is equal to x squared, which means x is equal to 60. And then this little distance here is 5. So x, well, 60 plus 5 is equal to 65. Yay! Well done. Nice job. Okay, I hope your brains are feeling like they have done lots of hard work today. We are going to finish off this Pythagoras section on Wednesday, and then we are going to move into our new topic after that. But well done for today, guys.
Yeah, well done, everyone. You guys have been great. You've been amazing, and this was a great lesson. Before we get into anything else, I'll let you guys go. How is everyone feeling? Some people said they have exams. How's everyone else feeling? Are you guys feeling good about maths this week? We always just want to keep tabs on. Are you guys okay? Like, how are you feeling? Just thumbs up, thumbs down. Anything that you want to share? Maybe you just got your marks and they were great, or you're still struggling. Just okay, the energy is great today. All right. I see you, Nokubonga. See ya, Kamva, Lutogozo. Cody's feeling good as well. Lerato's feeling positive. Lerato, I'm happy to hear that. I think last time we asked, said you were feeling a bit down. So I'm happy that there's been an improvement in that. Kenzan is feeling good. Zinhle, what are you nervous about? Do you have an exam? Are you one of those people who have exams coming up? Adora is feeling very good.
A PUA, critical but stable.
Yeah, I understand Apiwe. Yeah. Yeah, she is the best. Our teacher here is just great. Just the best. Bokamoso is feeling good. Tiamu is smiling, so I'm guessing that means everything's all good. No, I'm happy you guys are feeling good. We have one more
5 days.
5 days. Oh, yeah, that's very little. And yeah, hopefully you have been able to, like, some of the things that we've covered are helping you prepare. And remember, you can always go to watobe.co.za. If there are any lessons that you missed or you joined Watobe late, we've been having lessons for like a long time now. I think full last term, yeah, for quite some time now. So you can go to our website and click on lessons, and then go to grade 9, and then you can be able to find lessons that you missed, and just hopefully that will help you prepare. And we also have the app. Speaking of which, let me quickly jump to, you guys can still write your comments. I'll come back to them just now. Let me just quickly share my screen so we can give you your homework for this week. Cool. So on Thursday, we're doing mixed Pythagoras questions, and then that will be the last of Pythagoras. I think, I don't know if you guys feel the same way, but I think this has been a really great sort of like course, if I could call it that. this series of lessons for Pythagoras. I really enjoyed them, and I hope you guys enjoyed them too. Then we'll be moving on to area and volume, if I'm not mistaken, from Monday. So we'll be doing that from Monday. We're closing off Pythagoras. And then don't forget to go to the Watobe app, go to Theorem of Pythagoras, click on there, go to use Pythagoras in isosceles triangles. And basically go inside anything that's there, it's for you to do. If it's a video, watch the video. If it's a quiz, do the quiz. Just, of course, you must always be testing yourself. And there's also a quiz you guys can see beneath this. Try the quiz and do the questions, especially now before we have our last lesson, so that if there's any area that you're struggling with, you know that you can come and ask questions while we are still on the topic. Yeah, I think that's it from me today. If no one else has any questions or any comments, and Miss G, you're also good on your side, I think we can let you guys go. Enjoy the rest of your evening. I'm seeing a hand from Lerato. Lerato, do you have a question?
Yes, I have a question because I searched on the Watobe app for geometry of lines, which we are doing in our class right now, but I didn't find it.
Yeah, it's possible. There are some topics. I know grade 10s had the same issue as well. There are some topics where some videos are not there, and we are still updating it. It's an ongoing project. We are still updating it. There are much more things on the Watobe app today than they were, for example, this time last year. So we're constantly updating it. So it's possible that it's not there for now. But thank you for bringing that particular one to our attention. We'll look into it and then just give you an update, but yeah, we'll look into it.
There should definitely be some, because we did those together. So I think that
There should be, yeah.
there should be at least our lessons from when we did the classes, and I think there might also be some try-its that you can do.
Yeah, remember that on this, when you go, for example, to watch these videos that we do here, there are activities within the videos that we do in class and all those kind of exam type questions. So you can go back to the videos from the lessons that we had in the live class, even if it's not on the Watobe app, and you should be able to find very useful questions to check out.
Okay, ma'am. Thank you.
Cheers. You're welcome. All right. Bye, everyone. Go enjoy the rest of your evening. We will see you all on Thursday at 5 p.m. To finish off with Pythagoras.
Wednesday.
Yes.
Yeah.
Oh my goodness. Wednesday. Bye, everyone.
Bye, guys.
Bye.